Hi guys, so today we're going to be looking at a linear over linear function. And we start by factoring because this is going to make it easier to identify the x-intercepts, the vertical asymptote, and the horizontal asymptote. And we factor by common factoring the negative 3. So we common factoring negative 3 out. That's going to leave us with x minus 5 over 2x minus 1 because we can't simplify to 2x minus 1 any further. To identify the vertical asymptote, we're going to look at the denominator and set it to 0. So 2x minus 1 equal to 0. We're going to solve for x. So we're going to move the negative 1 over. It's going to become positive. And then divide each side by 2. That's going to leave us with a half. So we're going to have a vertical asymptote at a half. To figure out the horizontal asymptote, we look at the degrees. Since it's a linear over a linear, the degrees are going to be equal, so we turn to the ratios of the leading coefficients. So the horizontal asymptote is going to be equal to negative 3 over 2. To get the x-intercepts, we set the numerator to 0. So we have x minus 5 equal to 0, and then solve for x. So x is going to be equal to 5. Therefore, we have an x-intercept at 5, 0. For the y-intercept, we set all x values to 0. So c of 0 is going to be equal to negative 3, 0 minus 5 over 2 times 0 minus 1. That's going to leave us with negative 15. Therefore, we're going to have a y-intercept at 0, negative 15. So for holes, we do not need to worry about holes because holes occur when the numerator value cancels out a denominator value, and that did not happen, so we do not need to worry about holes. We use an interval number line to find out where the branches are located, and on this interval number line, we put any x values. So that's going to be the vertical asymptote and the x-intercept. This number line is going to go from negative infinity to positive infinity. We're going to have a half and 5. And then we're going to pick any values that go in between each interval. So from negative infinity to a half, I'm going to pick 0. You can pick any number here, it doesn't matter. I'm going to pick 4 here and a 6 here. And then we're going to sub these values into the equation, or the function. The numbers don't matter here, we only care about the signs in front of the numbers. So negative 3, we already have a negative here. We're going to set the 0 into the x, so we're going to have 0 minus 5. We're going to get a negative. And then 2 times 0 is going to be 0 minus 1, so we're going to have a negative. And that's going to give us a positive. So we start with the negative because it's a negative 3. 4 minus 5, we're still going to have a negative. 2 times 4 minus 1, we're going to have a positive. Therefore, this interval is going to be positive. Wait, sorry. Did something wrong. This is going to be a negative. Because a negative and a negative make a positive. Divided by a negative, it's still going to be negative. So over here, we're going to start with a negative because it's a negative 3. 6 minus 5, that's going to give us a positive. 2 times 6 minus 1, we're going to have a positive. Therefore, this interval is going to be a negative. Now that we have our characteristics, we are ready to graph. So we're going to start with our vertical asymptote, and that's at a half. And we represent our asymptotes with a dotted line. Use a different color. Don't forget to label. And our horizontal asymptote is at negative 3 over 2. That's going to be about here. Y is equal to negative 3 over 2. Our x-intercept is at 5. And our y-intercept is at negative 15. So, from negative infinity to half, our branch is going to be in the negative quadrant. So the top two are the positive quadrants, and anything on top of the x-axis or over the x-axis is positive. Anything under the x-axis is negative. So from negative infinity to a half is going to be in the negative quadrant. Make sure your line passes through the y-intercept, and your line is never going to touch the asymptote. It's going to run along it. And then from a half to 5, it's going to be positive. So it's going to be from here. So from a half, so this asymptote. Oh, this line looks kind of weird. Notice how when it touches 5, it enters the negative quadrant. So right here, from 5 to positive infinity, so this way, it's going to be negative. And we're going to label our graph. And we're done sketching. So the domain is equal to every x value except for the vertical asymptote because it cannot go through the vertical asymptote. So we're going to have squiggly bracket. X is the element of all real numbers where x cannot be equal to the vertical asymptote, so 1/2. And the same goes for the range. Y is the element of all real numbers where y cannot be equal to -3/2. For increase and decrease, we look at the slopes of the graph. So an increasing slope would look something like this, and a decrease would look like this. So for this one, this is a trick. You run your pencil along the slope, and it makes a decreasing line. And for this one is also decreasing. None of the lines are increasing, so we're going to put none here. And for decreasing, they both decrease, so we're going to do x. So it decreases from negative infinity until a half. We can't hit any vertical asymptotes, so the intervals are going to be split. And then it's increasing again from a half until positive infinity. For positive and negative intervals, we just look at our number line. So the first and the third interval are both negative, and then the middle one is positive. So from a half till 5, it's positive, and it's negative from negative infinity until a half, union from 5 to positive infinity. So for the behaviors around the asymptote, we're going to be looking at the ends of each line. Forgot my arrow here. So for the horizontal asymptote, as x approaches negative infinity, y is under the asymptote. So we're going to put -3/2 with a negative symbol here. That represents that it's under the asymptote line. As x approaches positive infinity, y is over the asymptote. And we represent that with a positive sign. So positive means it's over the asymptote line, and negative means it's under the line. For the vertical asymptote, as x approaches a half from the left, so from the left, we represent that with a negative symbol. So as x approaches 1/2 from the left, y is going down, therefore it's going to negative infinity. Y approaches negative infinity. As x approaches a half from the right, we represent it coming from the right with a positive symbol. Y is going up, so it's going to positive infinity. What does it mean when f of x is less than or equal to 2? First, we're going to solve this algebraically. going to bring the 2 over to this side and set the inequality to 0. And we're going to multiply the negative 2 by the lowest common denominator. We're going to distribute the negative 2 into the bracket and then simplify. We're going to get negative 7x plus 17 over 2x minus 1, which is less than or equal to 0. To get the vertical asymptote, we set the denominator to 0. We're going to get an asymptote at a half and an x-intercept at 17 over 7 when we set the numerator to 0. When we plot this point, it's going to be around here, around this area because my graph is not accurate. When f of x is less than or equal to 2, our function is going to be equal to this point right here and anything less than this point. When we write our inequalities, it's going to be this region right here because the asymptote prevents the line from exceeding this point. So when we write our inequalities, it's going to be negative infinity to a half, round bracket because our line cannot pass an asymptote, union, square bracket, 17 over 7, because our point is equal 2x, and positive infinity, round bracket, because it cannot actually be infinity, it cannot be equal to infinity. To prove this, we can look at our number line, our interval number line. I'm going to pick the values 0, 2, 3. When you set these values into the equation, you get a negative interval here, a positive interval here, and a negative interval here. And the function says less than or equal to 0, so it's going to be all the negative intervals. So when we write our inequalities, it's going to be from negative infinity to a half, round bracket, union, square bracket, 17 over 7 because it actually touches this point, to positive infinity, round bracket, which matches exactly the inequality we wrote right here.